Ciao friends, and welcome to the Whiteboard. In this episode, we will focus mainly on the VertiPaq storage engine. And in a previous episode, we introduced the formula engine. Today, we will see what happens when, depending on a different measure we use in the same report, what happens at the storage engine level. Sometimes a single query can be used to complete the calculation for a matrix that has subtotals, but other times this is not possible. And we will see when the storage engine can complete the execution or when the formula engine can offload some work from the storage engine when we use VertiPaq. Let's go to the whiteboard. We start analyzing this Power BI report where we have the sales amount by year and brand in a matrix. You see that the definition of the sales amount measure is a simple sum of the quantity multiplied by net price in each row of the sales table, and the result is displayed in this visualization by grouping the data by year, by brand, by product brand, and we also have the subtotal for the entire year and the grand total for all the years involved, and we're filtering only 3 years from 2018 to 2020. So if we go to DAX Studio and we see what happens when we execute this code, we see that the visualization, the matrix that we have seen in the report generated this query that is producing this result. And you can see in the result, we have the grand total by year 2018 for all the brands and the grand total for all the years and all the brands. The order of the visualization is different from what we have seen in the report. This is the first row, whereas the grand total was at the bottom. But the important part here is understanding what is going on in the formula engine and in the storage engine. So when we look at the execution, we have the DAX query that we have seen at the beginning. So the DAX query is executed and sent to the engine, particularly to the formula engine that has the full query plan. Now, the formula engine has to make a request to the storage engine because we are getting data by, we're retrieving data from the table sales, from the table product, from the table date. And if we look at the server timings pane, we can see that this request, this DAX query, only generated one storage engine query request. And if we take a look at the XML code, which is the language used to describe the query for the VertiPaq engine, this query includes the date year column, the product brand column, and it sums the expression that multiplies quantity by price. Now, if you know XML and if you look at this query returns a simple table. Every VertiPaq query returns a simple table that has a specific granularity. And the table returned by the storage engine, in this request from the storage engine, contains the year, the brand, and the sum of the sales amount for each combination of year and brand. Now, if we consider the content of this table, we will see that we have one row for each year and brand without the subtotals. So let's say that we have several rows with 2018, but each row has a specific brand and a specific total. Then we have 2019 and so on. But the table generated this way does not include the grand total and the subtotals by year that we see in the result. So who is computing this calculation? Well, in this case, because this calculation is completely additive, the formula engine knows that with a single request to the storage engine, it can build the missing rows in the final result by just adding rows to the result obtained from the storage engine. And in this case, we can imagine that we have additional rows for 2018, 2019, and 2020 for the subtotal and of each year, and the brand in this case is blank, and the result we have here in this row correspond to the sum of what we have in these rows. This calculation is performed by the formula engine, so it's the formula engine that is adding these rows, and it's also adding another row here which has a blank, and another sum here which is the sum of these three rows. So this calculation, the execution of additional aggregations that add rows to the final result that is sent back as a result of the DAX query is performed by the formula engine because in this case the formula was an additive one. But what happens if we have a calculation that is non-additive? So in that case we have a different execution. For example, in this case, we replaced the sales amount measure with a customers measure that computes the number of unique customers which we have for each cell of the result, which is the number of unique customers who bought a particular brand of products in a particular year, but then at the year level, how many customers we had regardless of the brand. And of course, because a customer could have bought products from multiple brands, it has to be computed only once in the total for the year. And again, in a grand total, we do not have to compute the same customer multiple times, even though it make purchases in different years. So in this case, the computation cannot be performed by the formula engine. And what we see in the server timings pane, we have now 3 storage engine queries. And in this case, we have a storage engine query that retrieves the data by, let's add some space here. We have the first formula engine that gets the data by year, brand, and the distinct count of the customer key in the sales table at this granularity. But the following query here computes the distinct count of the customer key in the sales table for each year. And there is a third calculation that does this without grouping by any column. So if we look at what is happening in this case, now we have a very similar initial DAX query that is sent to the formula engine. In this case, we have not 1, but 1, 2, and 3 requests to the storage engine. Each of these requests has 3 columns. Actually, only the first request has 3 columns because it's the year, brand, and the number of customers in this case. The second one has only the year and the number of customer, and the third one has only the number of customer. Now, the formula engine receives these 3 different intermediate results, and we call these data caches, and the result is a result that has all the rows that come from the first request, all the rows from the second request, in this case adding a blank for the brand. So in our brand, in our year column, in our customers column, we have at the beginning all the values here are just copied here. In this case, we have only the 2 values here, and in the last case, we have only the value here, and the blank is added here by the formula engine. And again, this is the result returned to the client, in this case Power BI, to display the result. So the formula engine can perform a few calculations and add other columns or other rows, as we have seen also in the previous video about the formula engine, whereas the storage engine, in the case of VertiPaq, is very, very quick, but it cannot perform additional aggregations as it was the case that we have seen here. So when we have additive measures, the additional rows, the additional subtotals, is something that is not executed by the storage engine. It is executed by the formula engine, this time adding rows to the calculation. When we have non-additive measures, this is what we will see. Multiple storage engine requests, each one for each granularity of the result we have to include in the calculation. Of course, this type of query requiring more requests to the storage engine could be slower, but the main goal it was to understand why we could see different behaviors of the storage engine depending on the type of the measure that we have in a report. So we have seen that the storage engine has the ability to perform calculations, but the VertiPaq storage engine has a limited set of features and cannot perform advanced aggregations. We have seen that with an additive measure, the formula engine can take care of the additional rows that are required, but in other cases, for non-additive calculations, we could see multiple storage engine requests for the same original DAX query. just because the calculation has to be performed at a different level of granularity by the storage engine. So I hope that you enjoyed this video about the storage engine. Remember, take a look also at the previous video about the formula engine and the other videos of the Whiteboard series. Enjoy DAX!